To be able to solve a problem like this, we need to be able to reference what our mu values are. So recall that your mu value is going to be the coefficient of friction, and that is dependent on the materials that you're using. So there's no way to, you can't really memorize that. You've got to take a look at some sort of reference table where it's been experimentally determined before. So what we know based on a reference table is that the mu, so the coefficient of friction between an oak block and an oak incline, is going to be 0.40. So let's start off first though by drawing our diagram. So it's going to look something like this, where that's at 40 degrees. And we have our oak mass that we're dealing with somewhere like this. So that has a mass of 25 kilograms. And recall, of course, that our components are going to look like this. So we have Fg, we have Fn, which is perpendicular to the surface. We have our force of friction going against the direction of movement. So this is moving down an incline. So our force of friction is going to be against that. So it's going to be somewhere over here, like that, parallel to the surface. And then we have our x and y components of Fg, which are going to be like this. So Fgy, Fgx, and the angle inside here is 40 degrees as well. That's always the same as the angle of the incline. So what else do we know? We know mu k, and that's 0.40. That's looked up in a table. We have m, which is 25 kilograms, and we're looking for the acceleration. So let's take a look at the perpendicular and then the parallel components here, because that's going to help us figure out what we need to know. So using the perpendicular components, we're going to be able to solve for Fn. So the sum of all the forces perpendicular to the plane are going to be equal to 0. And so that 0 is equal to Fn minus Fg cos theta, because they're in opposite directions, right? So Fn, 25 kilograms times 9.8 newtons per kilogram, which is the Fg component. So we can solve for, times cos of the angle 40. So we can solve for that. 2, 4, 5 times cos of 40. So that's equal to 188 newtons. That is the normal force, the force perpendicular to the plane. Next up, we can solve for the parallel. So the sum of all the parallel forces is going to be equal to MA. And that MA, if we take a look at all the parallel forces that we have, Fg sine theta minus FF. So start to plug in what we know. We have 25 kilograms. We're searching for A, Fg sine theta. So mass times G, which we just solved here, it's going to be the same value, which gives us 245. Sine theta minus. Now FF, recall that FF is equal to mu k times Fn. So we know mu k, which is 0.40, and Fn we just solved for, which is 188 newtons. So after we rearrange all this, and we actually have our theta value, that's going to be 40. So we can rearrange this, and what we're going to end up with is the acceleration is going to be equal to 82.5 newtons over 25 kilograms, 3.3 meters per second squared. Take a look at our diagram. Of course, our A is going to go in the opposite direction of our FF, so we might just want to add down ramp as our direction.